what we've said about them so far. So I've already handed out those notes about rational inequalities, but first I need to finish Wednesday's stuff. Let's suppose I give you a rational function. P of x over q of x. And let's suppose I want to find, say, the x-intercepts. How do you find the x-intercepts of this? Set y equal to 0, so y is the whole function. So that means p over q is set equal to 0. What's the only way a fraction can be 0? Okay. And what is 0 times q? 0. So you can just set the numerator equal to 0. So to find the x-intercepts, you can just set p of x equal to 0. Set the numerator equal to 0. Which is the same as what you would do. That removes, I don't know, an easy step from consideration. How do you find the horizontal asymptote? No, vertical asymptote is next. Set the denominator equal to 0. Set q of x equal to 0. And of course, solve that. How do you find the y-intercept? Set x equal to 0 and find whatever y is. And so these two are like, you need to do some solving. Unless you can't even plug 0 in, right? You might not. You might wind up dividing by 0, in which case there will be no y-intercept. And the last thing that we did last time, how do you find the horizontal asymptotes? Yeah.
Well, there's 3 different ways. So if the degrees are equal, it'd be the coefficient over the coefficient.
So take the ratio of the leading coefficients. What if the degree of p is less than the degree of q? In the case the degree of p is bigger than the degree of q, there are no horizontal asymptotes. You can still figure out how it behaves asymptotically by doing long division. You'll wind up saying that asymptotically it behaves like some polynomial of degree bigger than 0. So let's just remember those things and let's put them into practice. So the first is a question very related to that populations question that you just asked. Let's study a population of insects. In fact, let's study a population of bees, measured in this case in hundreds of nests, in some random wood that you decided to investigate, and in the 100-acre wood. By studying those and modeling, there's a particular differential equation that biologists use to get first-order approximations of population behavior, which we won't talk about in this class. Biologists would talk about it. If you want to see it in the calculus sequence, differential equations happens in second semester calculus. But you run that model and you find that the random population seems to be behaving like 5t cubed plus 2 divided by 2t cubed plus 10. In the 100-acre woods, it seems to be behaving like 4t cubed plus 2 divided by 3t cubed plus 10. And you want to know, well, as time progresses on to infinity, what do those stabilize to? What's the maximum population that these woods seem to be able to support? And let's try to do it. So let's think about what this even means. So as time goes to infinity, that means that I want to like study what happens when the input gets big. Graphically, that just means I'm looking for a horizontal asymptote, maybe a slant asymptote. So let's try to do what you should think whenever you see time going to infinity is that you're looking for horizontal asymptotes. So where's the horizontal asymptote of the graph given by that equation?
5 halves.
At 5 halves, because of this rule. Just take the ratio of the leading coefficients. And so let's put that into towards now. So as you let time go on to infinity, what does that false population tend towards? Well, it's like that, right? It's 5 halves, but what are the units that I should associate to it? In hundreds of nests. So as time goes to infinity, the random population settles at 5 halves times 100 nests, which I guess you should simplify as just being 2,500 nests. Nope, 250 nests. That makes sense? Seem reasonable? What about the 100-acre woods population? Yeah, so 4t cubed plus 2 divided by 3t cubed plus 10 has a horizontal asymptote at 4 thods, which this is like an actual applied problem. What's the decimal approximation of 4 thods? 1.3 repeating. So I guess that's not even an approximation, that's exact. Cool, so what does the population in the 100-acre woods settle towards? 133 nests. So as t goes to infinity, the 100-acre woods population settles at 133 nests. And you'll notice that the model actually says it should be 133 into thod nests. That sort of issue is always a challenge when you're trying to fit mathematical models to biological problems. There is this approximation issue. I don't know what a thought of a bee's nest is. I guess that's better than a thought of a bee, but how do people feel about that? Cool. So the last thing that I want to do is let's think about graphing rational functions by hand without the aid of a machine. So it turns out that that's often plenty easy to do when you happen to have a rational function that's, say, already factorable. So here is a rational function. X squared plus 1 times x plus 1 times x minus 2 divided by x plus 2 times x minus 1. So let's sketch a graph which has the correct x and y intercepts. So I guess that means we better find the x and y intercepts if we're going to make them be correct. Has the correct vertical asymptotes, so we better find those. Has the correct horizontal asymptotes. Has the correct positivity and negativity. It needs to be positive and negative in the right places. So let's go through and try to do that. So I guess the easiest thing is the y-intercept, I guess. How do you find the y-intercept? Yeah, just plug in x equals 0. So I guess you get 0 plus 1 times 0 minus 2 divided by 0 plus 2 times 0 minus 1. What's that equal to? Is it 1? It's 1, I think. All right, you might think it's going to be negative 1, but the numerator and denominator are negative. So it should have a y-intercept at y equal to 1. How do we find the x-intercepts? Yeah, set the top thing in the fraction equal to 0. So to find the x-intercepts, you just need to solve x plus 1, x minus 2 equals 0. What are the solutions to that? X equal to negative 1, and x equal to 2. I guess the next thing in the list is vertical asymptotes. How do you find the vertical asymptotes? Set the denominator equal to 0. So set x plus 2 times x minus 1 equals 0. Is the visibility of the screen okay? I absolutely can't see it. Oh, yeah. Okay. So even from here, I can just barely see what's on the screen. This might help too. There. Now at least I'm not casting a shadow. So what are the solutions to that? X equals minus 2 and x equals 1. So vertical asymptotes, those are like vertical lines that the graph gets close to. So I'll sketch in those vertical lines. X equals minus 2. X equals 1. All right, how do we find the horizontal asymptotes? Or just what is the horizontal asymptote? That line should probably be parallel to the x-axis, and it doesn't really look it. But at least it looks reasonably straight. Cool. So I have a lot of things, a lot of information already. Let's just try to figure out where this thing is going to be positive and negative. And let's think about where it could change from positive to negative or negative to positive. So throughout any of these points to the left of x equals negative 2, does it have any opportunity to change from positive to negative? No, it can only do so, well, either when it jumps from plus infinity to minus infinity or minus infinity to plus infinity, so a vertical asymptote, or it might change signs at an intersect, and those are the only places. So for all x values less than negative 2, it always has the same sign. What's an x value that's less than negative 2 that we could plug in? Negative 5. Maybe I'll be more extreme and say negative 100 billion, because then I can do it without doing any evaluation. Where is this thing supposed to have a horizontal asymptote? At y equals 1. So if I plug in a really, really, really negative and really, really big x value, what sort of y value should I get? Something that's really, really close to 1. And numbers that are really, really close to 1, are they positive or negative? Positive, right? Like, it'll either be like 0.999999 or 1.00000. So let's write that down. So to get the right positivity and negativity, when x is less than, x is Alternately, we could actually just plug in x equals -3, right? That's still a valid thing to do. But then I'd actually have to do computations. I'm trying to avoid that. So, for all x values less than -2, will it be positive or negative? Positive. So, we can even draw that in. So it'll be positive when x is really, really extremely negative. And now I need to get to this vertical asymptote. And the only ways I can do that are I can either go up there or go down there. Is the choice where I go to -infinity reasonable? Because I would have to become negative to achieve that, right? But it can't. It has to stay positive. So, should it shoot up to plus infinity or minus infinity? Plus infinity. Nice. So next, between -2 and -1, it will either always be positive or always be negative. What's a sample point we could plug in to check?
0.
Well, no, not quite. Between -2 and -1? -1.5. Well, let's do that. Let's do what you said also. Let's plug in x equals 0. In fact, we already have. What y value do we get when x equals 0? 1. So, that tells me something, right, though. That tells me that over this interval, it will always be positive. But yeah, let's plug in -1.5 and see what we get. So let's see, when x is equal to -1.5, so let's see, we end up with -1.5 plus 1 times -1.5 minus 2 divided by -1.5 plus 2 times -1.5 minus 1. And on the one hand, we could evaluate this on the nose, but let's just decide if it's positive or negative. -1.5 plus 1, positive or negative? Negative. -1.5 minus 2. -1.5 plus 2. -1.5 minus 1. So, without actually evaluating what those are, I saw a negative times a negative divided by a positive times a negative. Will that be positive or negative?
Move it over a little.
Yeah.
Thank you.
And right, since I don't care about having a graph that's like accurate on the nose at every point, that's just fine. How many people end up like evaluating that on the nose? Yeah, you would have gotten something. I guess it would have been negative. So that tells me that all the way from x equals 0 to x equals -1, it has to be negative. And it has to reach this vertical asymptote. So it can't go to plus infinity because it has to be negative. So it has to go to minus infinity. That makes sense? And now let's see, all the way from x equals -1 to x equals 1, it has to either always be positive or always be negative. Will it be positive or negative in that range? Positive, because we've already checked at 0. At x equals 0, it's positive. So it'll be 0, it'll be positive all the way from -1 to positive 1. Notice that means we had to cross the horizontal asymptote, which is just fine. Sometimes that happens. And now I guess there are two different regions to check. All the way from 1 to 2, it will be positive or negative. And all the way from 2 to infinity, it will either always be positive or always be negative. How could we check? What's the sample point we can plug in between 1 and 2?
1 billion. Positive 1.5.
Positive 1.5. You answered a different question. Yeah. That's the answer to the next question that I'll ask. When you plug in 1.5, let's try to figure out if what we get is positive or negative. And I'll try to do it without even writing anything because I'm low on space. So 1.5 plus 1, positive or negative? 1.5 minus 2, positive or negative? Negative. So I see a positive times a negative, so the numerator is negative. 1.5 plus 2. 1.5 minus 1. Positive. So the whole thing is positive or negative? Negative. I'm glad you guys remembered that the numerator was negative because I had forgotten. I need to write things down if I'm going to remember them, but. So, nice. That means that from x equals negative 1 to x equals 1 to x equals 2, it has to look like that. Now, when you plug in x equals 1 billion, what must the y value be close to without plugging in? It has to be close to 1, because that's where the horizontal asymptote is. So when you plug in x equals 1 billion, you have to get a number that's close to 1. Is a number that's close to 1 positive or negative? So we sketch a cartoon of the graph, and it looks something like that. What do people feel about that? That seem okay? Maybe we'll do one quick thing to check. So the notes that I actually handed out today are intended to take less than half of the time, so I don't feel so bad about time yet. Let's plot it computer or using a computer. Let's plot x plus 1 times x minus 2 divided by x plus 2 times x minus 1. That should be fine. It's really nice that Wolfram Alpha gives you your input and footing point. That's the thing I actually wanted to graph, right?
Yep.
Cool. That's the long viewing window. That looked about like the graph that we generated? Yeah, maybe it looks like we're getting close to the horizontal asymptote faster than the actual graph seems to be. It's a cartoon graph, so you expect details not in that list to maybe be. How do people feel about that? Does that seem okay? Cool. So now, well, I'll pose for you guys a question. Do you guys want to do one more example of graphing? Is there interest in one more example? Oh, okay, yeah, let's do it then. And let's talk through it. So let's go through the exact same steps. I'll write significantly less. And we'll just draw the facts as they come up. So looking at this function, where are its x-intercepts? X equals 1, x equals negative 3. This contributes an x-intercept at 1. There's an x-intercept at negative 3. X-intercept at 1, x-intercept at negative 3. Where is the y-intercept? At 3 halves? Where are the vertical intercepts, vertical asymptotes? X equals negative 2 and 2. where is the horizontal asymptote? Good. Is that enough information to sketch this graph? Yeah, I mean, maybe there's some like positivity, negativity stuff to check. So without doing any evaluation, is the thing positive or negative from negative infinity to negative 30? So for an x value that's way out this way, what will the y value be close to? It will be close to 2, because that's where the horizontal asymptote is. So will that y value be positive or negative? Without doing any evaluation. So we know that it achieves this horizontal asymptote. Has to come down to 0 when x is negative 3. What's an x value between negative 3 and negative 2? Negative 2.5. And again, I'll try to do it without doing any actual writing. Try to plug in x equals negative 2.5. Are these pieces positive or negative? 2 is positive. When you plug in negative 2.5, is x minus 1 positive or negative? Negative. So I'll just try to keep track how many negatives. So there's 1 negative. X plus 3. Positive. X plus 2. Negative. X minus 2. That's 3 negative, so will it be positive or negative in that range? Negative. And I need to make it to that vertical asymptote. So that's where it has to go. Between x equals negative 2 and x equals 1, will it be positive or negative? In this range. Because the only place it can change sign is at x-intercepts and vertical asymptotes. Well, what's a sample point in that range? 0. We already plugged in 0, didn't we? Yeah. What did we get? Positive or negative? Positive. So it needs to go from plus infinity. It needs to actually achieve that y-intercept, come down to that x-intercept. What's the number between 1 and 2? 1.5. 1.5. Imagine plugging in that 1.5 into the function. Will you get something positive or negative? Negative, I think? Yeah. So presumably it's because like 3 things are negative, or is it because 1 thing was negative? Doesn't matter. We'll achieve that vertical asymptote. From x equals 2 onto x equals infinity, will the thing be positive or negative? Positive, without doing any evaluation, because you have to achieve that horizontal asymptote. So you wind up with a graph something like that. How do people feel about that? That seem okay? Cool. Another thing that you might notice is this had like a degree 1 term in the numerator. It was x minus 1 to the power 1. So that tells you that at x equals 1, that's going to change from negative to positive or positive to negative. So at that x-intercept, it needs to change sign. So you can use the power on those things to reduce computation even further. Any questions about graphing before we move on to thinking about inequalities? Cool. Let's solve some inequalities. Now, we had like an algorithm for solving inequalities when it came to polynomials, right? If you want to solve function is bigger than 2, then solve function is equal to 2. That'll give you some number of points where it might change from positive to negative. then you check between and beyond and decide where it's positive and where the inequality is satisfied and where it isn't. So first you figure out equality, then you figure out inequality. Now let's try that with this function. And we'll find out that that strategy doesn't quite work. So let's try to solve the inequality. X plus 1 divided by x minus 1 is bigger than 2. So step 1, where is x plus 1 divided by x minus 1 equal to 2? Let's try to solve that equation. What would you want to do to solve that equation? Let's move in for step. Multiply both sides by x minus 1. I see a denominator. I see a fraction. That fraction makes me sad. It makes it harder to solve. So let's get rid of the fraction by cross multiplying. So cross multiplying, x plus 1 is equal to 2x minus 2, multiplying over the x minus 1. Is that now an easy equation to solve? Yeah, I guess you would subtract x from both sides and add 2 to both sides. So you'll wind up with x equals 3. Nice, so there's the solution to equality. Now we're going to play the game, the left and right game. So there's x equals 3. And maybe we'll start with this. Does x equal 3 solve the inequality that we started with? Should we include or exclude that endpoint? Exclude. Because when you plug in x equals 3, assuming that that algebra is correct, you'll get exactly x is equal to 2, but 2 is not bigger than 2. So x equals 3 will automatically be excluded. What's a number that's bigger than 3? Oh, yeah. Yeah, maybe I'll even zoom out just a little bit. It's still big enough for everyone to read, or was that bad? We're still okay? Okay. What's a number that's bigger than 3? 4. So let's plug in x equals 4. We could just as well plug in x equals 4 billion instead and use asymptotics to decide something, but x equals 4 will work. We'll get 4 plus 1 divided by 4 minus 1, which is, what is that equal to? 5 thirds. Is it? What's 2 as a fraction with a 3 in the denominator? 6 over 3? Is 5 over 3 bigger than 6 over 3? No. So that's bad. So everything to the right of 3 is not in the solution. What's a number that's less than 3? 1. Let's try to plug in x equals 1. All right, so it looks like we get 1 plus 1 over 1 minus 1. Wait, something's weird, isn't it? So we're noticing something bad happening already. There's a hole in the domain. So x equals 1 isn't even in the domain. I don't know, so I guess if you just blindly want to salvage the strategy, you say, well, okay, 1 wasn't in the domain, but surely there's another number that's less than 3 that we could plug in. What's another number that's less than 3? 0. Sean, what do you get when you plug in x equals 0? Is that bigger than 2? No. So this number at x equals 0 failed to satisfy the inequality. So it looks like, if you believe this strategy works, that everything to the right of 3, x equals 3, is not a solution. Everything to the left of x equals 3 is not a solution. X equals 3 is not a solution. So what do you predict that the solution to this inequality is? That's what our algorithm would predict, right? We excluded the endpoint and we excluded everything else. There's nothing left. There are no solutions. On the other hand, We can graph x plus 1 divided by x minus 1. Where is its vertical asymptote? X equals 1. Where is its horizontal asymptote? At 1. Where is its x-intercept? Where is its y-intercept? I think that's enough information to sketch a graph of this thing. So the graph, I think, should look something like this. Fair enough. And in fact, we even know that when x is equal to 3, y is equal to 2. So it needs to go through the point 3, comma 2. Not drawn to any sort of reasonable scale. But wait, now looking at this graph, where does it look like the y values are bigger than 3? Can you find any x at any point on this graph where the y value is bigger than 3?
2.
Yeah, x equals 2 would do, because that would put you at like that point. In fact, it looks like all of these points make us happy, excluding that endpoint. So it looks like there is a solution. It looks an awful lot like the solution is 2 to 3. No, 1 to 3. So that's like bad, right? We have this algorithm that's supposed to solve inequalities. And we ran that algorithm. One, we found that like it just breaks when you try to plug in x equals 1. But if we just try to fix it by plugging in something else, it gives us a wrong answer. So we need a way to salvage this strategy, but this picture even tells us how we can salvage the strategy. The inequality changed from being true to false at x equals 3, and it changed from being false to true at x equals 1. What type of value was x equal 1 for this function? It was a vertical asymptote. So vertical asymptotes can change inequalities. Inequalities can change when you go over a vertical asymptote. So if you want to solve an inequality, you need an extra step. First, check for all places where equality happens, because that's a place where inequality could change. Then check for all bad points. Check for all vertical asymptotes. Because in a vertical asymptote, the inequality could change. That makes sense? Let's try to actually run the algorithm correctly this time. Let's solve the inequality. Yeah. Let's leave that being strictly bigger than. So step 1, solve x plus 1 divided by x minus 1 is equal to 2. In fact, we already did this. What was the solution to x plus 1 divided by x minus 1 equals 2? Good. We just did it on the previous page. Where are the vertical asymptotes of the ingredients of that equation? So let's pick those points. There's x equals 1. There's x equals 3. Let's decide first whether those points should be included or excluded. Can we even plug x equals 1 to the left-hand side of the inequality? So it can't possibly be in the solution. It's not even in the domain. So x equals 1 has to be excluded, because it's not even in the domain of x plus 1 divided by x minus 1. What about x equals 3? Should that be included or excluded? Still excluded, because 2 is not strictly bigger than 2. If this was loose inequality instead of strict, then I would include 3. And now we'll pick sample points. What's an x value that's less than -1? 0. We already plugged in x equals 0. When you plug in x equals 0, do you get something that satisfies the inequality? What's a number that's between 1 and 3? 2. What do we get when we plug in x equals 2? Let's see, we'll get 2 plus 1 divided by 2 minus 1, and we want that to be bigger than 2. Is that true? Because I guess that's 3 is bigger than 2. So that tells me that all the numbers in between these two are solutions. What number bigger than 3 did we already plug in?
4.
X equals 4. Did that solve the inequality? So it looks like the solution to this should be the open interval from 1 to 3. Did that agree with what the graph seemed to indicate? Yeah. Nice. So here's the strategy if you want to solve an inequality involving rational functions. Step 1a, find the solutions to equality, just like we always did for polynomials even. Step 1b, find the vertical asymptotes. And those aren't so hard to find. How do you find vertical asymptotes? Set the denominator equal to 0. And in fact, you should take all of the ingredients of the function and find all of their vertical asymptotes. You should check between and beyond those asymptotes, the vertical asymptotes in the solutions, to see what intervals solve the inequality. And as always, you should be careful with endpoints. In fact, is the location, take the location where you see a vertical asymptote. Is that location ever going to solve the inequality? No, it's not even in the domain. X values where you have a vertical asymptote will always be excluded. And finally, write down the solution in interval notation. So I think that in the time allotted, for my 40 seconds I have, I don't think I have enough time to run through the algorithm. So here's what I would like. Well, in fact, maybe here's a good bit of incentive. This very problem may well appear on that quiz on Monday. So think about this, try to run the algorithm, sketch a graph, find the solution. Yeah.
Are those going to be on the test for Monday?
I haven't made the quiz, so I would consider them to be fair games. I would consider something as long find the open castle lesson law. So let's see. I think I've gotten 2 emails from groups saying that they want to be groups. If any of you guys want to send me an email saying I would like to be in a group of this 7 people, go ahead and do it. If you do it after I've already made the group assignments, then I won't heed your request this time, because I won't remake everything from scratch just for you. Yes. So getting it to me sooner will result in me grading it sooner. So did you just already have it done? It's just somewhere else? Okay. Are you on campus in Boston, or do you live far away?
I'm on campus going on this weekend.
Yeah, if you can get it to me today, then I might grade it this weekend. Make sure to turn that in to get on with so that I can see how many things I took out.
So I have to go like meeting finish and documents and it's really cold.
Okay.
Do you have time to meet right now?
I have another class that happens right now.
Okay, then I will. Is it 11 to 12?
My office hours are. Wait, I'll just pick the office hours to be times when I'll naturally be there without thinking.
Yeah.
So, yeah, 11 to 12 on Monday.
Okay, cool. I'll be there on Monday.
Yeah, that's the best thing to do.
Okay. Sounds good.
Yeah, you can also email me questions if you can place them. Especially compared to outside.
Yeah.
I don't know if my girls are doing it right. I didn't get any of those.
Nice. So it's entirely possible that this has no rational roots. Like that can theoretically happen. So what things did you try to plug in? Just because I don't see the X values written down.
I really don't care.
I just kind of checked what.
It's the only like code I have right now.
Just
Oh, really?
see what
Yeah,
it is
I
for
need to run it.
expressions. First,
Well, just,
Fine.
I just want to make sure that it's possible that there are no fractional. I just want to make sure that you plugged in the right thing. So you saw that. What were the choices of P?
She is plus or minus 1, plus or minus 2, plus or minus 4,
It's
plus or
like
minus 3.
it's like the latte.
And you?
Yes.
Plus or minus 1, plus or minus 2, plus or
All I
minus
want
3,
right now.
and then plus or minus 6.
So the resulting X values then are
Oh god, yeah, sweet.
plus or minus 1.
Okay.
So all the choices when Q is equal to 1.
Wait, where are you getting those numbers from?
Yeah, so these are all of the, so this is P equals 1, P equals 2, P equals 4, P equals 8.
That's how it is though.
All the ones with a Q.
Like anyone knows.
I know, but like you're already spending the night of
Because they're T over Q.
Oh, because
I
P
spent
over
the very
Q, I
first
see.
night at this house.
But something you see immediately,
I
because that's
guess,
just
yeah,
one.
I guess we
It's already reversed. That's 2, it's already, that's 4, it's already.
Okay.
Oh, well, props to you because the me and Jaden went out.
And not the day. Not those. Like this both nights. It's not.
Okay, that makes sense. I was just getting it wrong.
Okay.
I'm glad I asked.
Yeah. Yeah, so those should be all the X values that you took.
Okay, thank you.
It's like I was kind of new that I was just like wouldn't get mad at me, but now that I'm not with it, it's like, I mean, obviously, I could have said no more. It's probably really fast.
Wow. Music are all culture. French exam? Like, it was so bad. She's like, and don't leave anything blank. Try at least to put something down. And I'm like, what do I put down? There's no word bank, there's no multiple choice.